Here I will do a short introduction of these use cases and how we are able to apply machine learning to solve some of the common IT ops problems and use cases. And then rest of the session will be led by Manoj Panda, who is our AI ops engineering leader. Hi, welcome to this session on applied machine learning to top IT ops use cases. This is Tejo Prayaga, head of AI ops product management and marketing at CloudFabrix. Later in the session, we will be joined by my colleague Manoj Panda, who is the head of AI ops engineering at CloudFabrix. Before we go into the session, I just briefly want to share on how we came up with this session. When we talk to our customers in the enterprise IT space, they specifically wanted to understand how ML can help address their problems in the day-to-day functions. And that is precisely why we came up with this session. And here we will be sharing the right amount of information without going into all the nitty-gritty details. And we will cover few common use cases and scenarios that are broadly applicable in various IT organizations. So with that, let me start with the agenda. So what we are going to do in the session is a quick recap of what is artificial intelligence, what is machine learning, and some of the key types involved in the machine learning. And after that, what we will discuss is the application of machine learning to address some of the popular IT use cases. And then Manoj is going to take over the session and he will talk about some of the machine learning technical stacks that we have used, some of the popular algorithms and frameworks we have used in our solution. And then he will do a deep dive into some of the use cases which can be addressed with popular machine learning tasks. And then finally, we are going to talk about a very exciting use case where we are using OpenAI, which is one of the leading organizations in the AI space, and they have come up with one of the world's largest NLP model, and we were able to actually integrate with their service. So Manoj will provide more details about how we are integrating with OpenAI. AI is the simulation of human intelligence by machines, and an application of AI is machine learning, which is basically the concept of a computer program learning and adapting without human intervention. So in this session, we are going to focus on the common tasks, which are the supervised and unsupervised learning. And within that, we will talk about regression, classification, and the clustering ML tasks. And a deep learning, which is also used in our solution, but just in the interest of time, we are not going to focus on deep learning in this particular session. So clustering. So clustering basically is an unsupervised machine learning type of task. And in clustering, so we can apply clustering to alerts. So in this scenario, what happens is IT organizations, IT ops teams are inundated with hundreds of thousands of alerts or even millions of alerts generated by IT operational tools and the monitoring tools. And it becomes really challenging to understand what are the core problem areas or categories of problems that are hidden in this particular alert stream, and it becomes humanly impossible to just sift through all these alerts and get to the real problem. And this is where your clustering can come into picture. And using clustering, what you can do is you can turn all of these hundreds of thousands of alerts into a meaningful set of problem categories represented by clusters. So each cluster can represent a problem category. And in this example, we have converted 138,000 alerts into 124 clusters. And you see that each cluster is talking about a meaningful problem which the teams can easily understand. So here you see things like device unreachability, device unreachable, or processor load status, or memory pool usage. These are all the clusters that the machine came up with by looking at all the alerts that are in the input. And here we are using a algorithm. It's called DB scan, or a hierarchical DB scan. In the same way, we can do the clustering for logs. Imagine in your IT environment, you have a lot of applications, lot of infrastructure devices, all of them generating hundreds of thousands of log messages. And what you want to do is typically you may want to identify similar strings or patterns in your logs. You want to identify what are the anomalies in your logs, or simply you may want to do some volume analysis for a specific type of cluster, or sometimes you may want to identify a specific error or a keyword if it is more prevalent or less prevalent. So using log clustering, what you can do is take all of these log messages and simply treat them as bunch of message categories or clusters. So in this example, we have taken 30,000 log messages, and now you see that each one is a cluster just talking about one particular type of message occurring repeatedly over time. And the classification, now this is a supervised machine learning type of task, and using classification we can address a few other problems. One is in the incident management area, where when you get incidents, when you get new incidents, your IT ops team members, your service desk team members, they are generally looking forward for your previous incidents to get clues or to get hints around how these incidents are resolved in the past, what were some of the workflows that were used, or what were some of the knowledge articles that were used or reviewed to address the past incidents. So using the classification technique, you can identify what are the similar incidents to a current incident. And you can do this based on a description and many other parameters that are in the incident. And here we can use algorithms like k-means. A second use case is around predicting the incident assignment group, and it's a very popular use case. Here, when new incidents occur, it is very important to route these incidents to the correct team that is responsible for addressing those incidents. And what we can do here is learn from historical incidents on how these incidents have been routed to various teams, which can be like a database team, hardware team, middleware team, or so on. And based on these historical incidents and how they have been routed to these teams, the new incidents and the future incidents can be routed to the same teams. And information extraction, this is another popular use case which can be applicable to multiple scenarios. You can apply this to log messages, you can apply this to trouble tickets, and incidents, even alert messages. So essentially, where you have a bunch of this text message, what you can do is you can do keyword extraction and identify what are the entities within that input, and also you can see which ones are more prevalent. And here it is more like a word cloud type of visualization. And the fourth use case is a classification or enrichment using an external service. And in this example, we are using OpenAI. Here we see that there is a text message, an error message that we found in one of the logs, and it is very cryptic message. The L1 or L2 operators, they don't understand what exactly this is. It's very cryptic. Something related to Java is what they know, but nothing more than that. So what we can do is take that message as is and pass it on to a external AI service, which can do natural language processing, and then take back the result or the prediction from that. And in this example, you can see that it is clearly highlighting uh, the response saying that the error is caused by a fact that Jenkins server is not able to verify the certificate on GitHub server, right? So this is easily understandable. It can be very easy to interpret and work towards a resolution, and this is very useful for your L1, L2 team members. So here we are showing you a screenshot from the tool, but essentially what we have done is an API level integration, but just for you guys to easily visualize and see what's going on, I just put a screenshot of the input and the output from the tool. Just a quick note on OpenAI. So OpenAI is basically an organization that was originally co-founded and backed by Elon Musk. And it is a for-profit organization, so with a goal to develop very large artificial general intelligence models that can outperform human performance, right? And one of the models is GPT-3, which is the third generation of the generative pre-trained transformer model. And this is one of the largest model ever developed, with almost 175 billion parameters. And this can actually produce incredible human-like text. It can do very powerful natural language processing. What we have done is we think that we are one of the early adopters of OpenAI, specifically to address AIOps use cases. And another use case here is statistical correlation. And this is technically not machine learning, but what we are doing is using statistical correlation to understand how metrics behave in a correlated way. Either they are rising together or they fall together, or sometimes it could be indirectly correlated. So if one metric goes up, the other metric goes down. And it is very important to understand when metrics behave in a correlated way. For example, in this scenario, we are showing you that there were calls per minute going up. And because of the calls per minute going up, the latency is also increasing and the latency is impacted. And it is important for the IT ops personnel to understand this kind of correlated behavior. And we are using ML algorithms like Pearson, Kendall, or Spearman correlations. The next example here is regression. One of the most popular type of machine learning task, which is a supervised machine learning. And you can use regression analysis to identify anomalies in any kind of time series metrics data. Let's say you have a CPU utilization, and suddenly you see a spike in CPU utilization, which is a deviation from your normal usage pattern, and you want to identify that. Then you can use regression analysis. And you can also do forecasting with regression analysis. Let's say you have a disk utilization, and you want to predict the disk utilization, or when your disk is going to be full. Then you can use regression analysis to do that kind of prediction and forecasting. And if you also want to understand the baseline usage within your environment, right, you can also use regression. So in this example, we are showing you a interface packet discards metric, and this is a very important metric for one of our network operations teams. So what we have done is we ran the regression analysis, and it came back and provided you the lower bound and upper bound, which is the baseline, and any data above that, you can easily identify them as anomalies. And any data which is past this particular point is all predicted data. It's all prediction and forecasting. And using this analytic, your team members can also be much more operationally ready to address these kind of peaks when they happen. So with that, I'm going to hand it over to Manoj, who will do a deep dive into some of the use cases and the ML tech stacks that we use in our solutions. So Manoj, the floor is all yours.
Hey, thank you, Tejo. So my name is Manoj Panda. As Tejo mentioned, I lead the engineering division in CloudFabrix for the AIOps. And I'll walk you through what tools do we use, what are the technology that we use, and what algorithms we use, and I'll also walk you through some of the demos, both from CFXDX that my colleague Satyan went through, and I'll see how we can use CFXDX for ML also. So with that, we do support, all kinds of neural network, non-neural network, and NLP-based modeling. And our primary tool for our development environment is Python. So we use scikit-learn and of course all the libraries like NumPys and Pandas for all the data analysis. For neural network, we use Keras, TensorFlow, and PyTorch. And for NLP, our preferred choice is OpenAI, as Tejo walked you through some of the OpenAI's capabilities and how great they are. And we also use NLTK and Spacey. So we have integrated with OpenAI, and also will be giving you demo for that. So we use primarily clustering for alert clustering, and as well as log clustering and log regression, log volume regression. For clustering, we use dbScan and HTBScan. HTBScan actually gives us very good results. And wherever we have a priori knowledge of number of clusters, we know that we need to create 4 or 5 clusters, then we can use k-means. When the cluster size, number of clusters are unknown, the choice is HTBScan. For regression, this takes a time series data, timestamp, and value, and Prophet gives us the best results, but we also have ARIMA and AutoARIMA that we use. And all these are provided both through our CFXDX and through our UI. And the default choices are whatever we find good. For example, we use HTBScan for clustering, Prophet for a regression by default. And if you need to change something, you have to go and specifically change to different models. And for classification, we use support vector machines and k-nearest neighbors. So these are the main algorithms we use. But of course, we also use, for vectorizations, we use TF-IDF and word2vec and so on. This is some of the pipeline that we have created. So we have a machine learning pipeline that you go through a series of steps. Pipeline is nothing but a series of steps. So we first go through data validation to check for data sufficiency. Is there enough data for me to do a good accuracy, to get the good accuracy with my model? Is there enough variance in my data? So if I'm doing any predictions and all, if there's a variance of data, then you get better predictions. If it's a flat line, you won't get good prediction data. For regression, we allow the user to do different roll-ups, 1 hour roll-up, 2 hour roll-up, or 15 minutes based on the data and data sampling, and how much of what duration of data they have, right? And as I mentioned, we use Facebook Prophet as our default algorithm for regression, but you can also select auto-ARIMA or ARIMA and provide prediction time. We recommend 7 days. If you have good duration of data, 7 days is an ideal. But if the data range is very short, 1 day. But the data is sizable, then you can go to 15 days. But the prediction accuracy would kind of diminish after as you go to a long-term prediction. And for seasonality, we can just let it auto detect all the seasonality for whether it's weekly, yearly, or daily. But you can also go, and if you have a priori knowledge, this is the seasonality I have, you can set it, and then you can have either seasonality mode as additive or multiplicative, or growth as linear versus logistic. Right. So this is a little detailed diagram, if kind of flow diagram, what happens as you when we go to customers. We if they can provide us some historical data, it could be just CSV data, or it could be a data source that we can connect through a CFXDX and pass through a regression algorithm, and that creates a baseline. As Tejo walked you through, we create on the baseline. It has the upper bound, the lower bounds, the predicted values, and we also create maximum, minimum. We created the daily, weekly, upper bounds and lower bounds, and all the data is created. And this data is used for as a new live data comes in to detect, is there any anomalies, is the data fitting into our thresholds, are they above or below, then we do the anomalies. And then we can go and annotate the metrics, say these are the metrics, these are the anomalies at this time, and then we can visualize that through our visualization tools like what we have. So with this, I'll go into a demo of some of the things that we do. So I'll start with the regression. So regression uses any metric data. So let me look what metrics I have. So I use the command that you went through just a little while back. So I see that I have a Prometheus has data, the metric range. So I can use that tag for my regression. So now I've set to Prometheus as my data source, and on this I'll run the regression. So for this, I need to go through the so Prometheus like a query. You get the data, the metric is, and then I'm trying to get for CPU total time for a particular instance. That instance is 1095, 124, 114 that I use for filter, and I'm getting last 30 days of data with step of 60 minutes. And then if I just run this data and I want to see what kind of data I get, this is the data I get. I get for the instance, I selected for one particular IP address. For that IP address, for the CPU total time, what is the timestamp and what is the value, right? So these are the two things, timestamp and value is what I need for the regression. So now I can pass that to my regression algorithm. So I pipe that to my CFXML, and then I want to do 1 hour buckets. So I got this data and I create a 1 hour bucket and I run through and it goes through the data, then it gives you back this data. This is, I chose not to pipe it to a file, but I can also pipe this to a file. But right now, let's look at the data. I see the timestamp and the trend. We have the lower bound, upper bound. We also have the additive terms, and we have the daily values, weekly upper bounds and lower bounds. So all this data is generated with just one single line, just piping the data that has timestamp and value, pipe it to a ML sync, and then it gives you back this output. And this output can be used for any data visualizations. You can write it to a file by piping it to the file and then do all kinds of analysis on it. So to just pipe to a file, you just pipe it to a file like Satyan walked you through. So I won't go through that. So now let me go back to the presentation and walk you through the next pipeline that we have, which is the unsupervised clustering pipeline. So this, as we go through the steps, we pre-process the data, just the standard things, convert to lowercase, remove any punctuation marks, remove the stop words, remove the digits. Then we go through the regular expression-based devariabilizations that removes anything that is kind of repeating variables that impact your clustering. You can choose it or can leave them if they really help you. So you can remove the date times, email addresses, interface numbers, and so on, and IP addresses you can remove. And once you've done through that, you choose a vectorizations, and we have seen good results with TF-IDF, but you can use word2vec or account vectorizer and other vectorizations, and you can experiment. So we have in the UI or in the CFX-DX, you can run it multiple times until you get the best results and see which hyperparameters gives you the best results, and you can use that. And once you've gone through these steps, now you finally come to the ML algorithm for clustering. You can HDB scan, and if you're using HDB scan, you can give minimum cluster size, minimum samples. Do you want to predict the data, and do you allow single clusters? And then once you do this, it goes and creates, if you want to predict, it creates a pickle file. So as a new data that comes in, that would get classified to different clusters. Right? This is kind of the flow diagram of it, and as you've seen, we take the historical data either through a CSV file or through a source mechanism. We go through the pre-processing, run the clustering, and create clusters. So these clusters have the generic names like cluster 1, cluster 2, and so on, and user can assign labels to make them more meaningful. Cluster 1 is represented ICMP unreachable, cluster 2 represents storage out of space, right? And once these are relabeled and the pickle file is updated, as a new alerts or new logs, anything that has a textual data, that goes through again the same process of in the pre-processing the data, and then we use a pickle file to classify them into different clusters, right? And then we can use them for clusters. If you want to do alert policies, you can correlate or suppress them. If you have logs, you can do, on top of that, you can do regression to get more data, right? So let me go back, what kind of classification or clustering that I can do. So let me look at some alerts. So tags alert. So I have some alerts from Elasticsearch. I'll use that. So let me look at the data for the alerts. It has a lot of data, but what I'm really interested is the message, right? And what kind of message the alert has, and that will be primarily used for clustering. So then of course the created values used for grouping them into different clusters. So now what I'll do is I will take this star, and let me look at the tags clustering. So I'll pipe this to our clustering algorithm, and the data had message, and our algorithm expects them as descriptions. So I'm just doing the translation to description, and then I pipe it to to my log clustering. And I want to see the data. Of course, I can do another pipe to pipe it to write to a file, which we'll do maybe later if you want to see the actual how the data got created. And here, I want to see the data on my screen. So I got the data, it took the description, and then added different clusters. So let me see how many clusters it created. So it created a total of 7 clusters. And if you see cluster 4 had the maximum number of alerts got assigned to that, 37% or close to 38%. And we're showing here top 5 clusters that had alerts assigned to them. And you can look at this and then of course do, either you can do regression on top of this, or you can do alert clustering for your policies for correlation and suppression. So let me try to write this to a file. I'm here. Okay, so let me pipe this to a file. So I now should have a file. Very good. Now if I go into clusters alert CSV, so I see the data. I can of course open it with. So if you see this got added to cluster 5, and we also seen that some of the devariations happened here. It added dollar signs and all. So this is the different clusters. So you can look at it and then see which alerts got assigned to which clusters and so on. So so that takes care of our, we had a regression pipeline, then we had a clustering pipeline. We'll go to slightly more advanced pipeline, which we have, which is called clustering. And you cluster the logs, and then you do regression. So now you cluster 2 logs into different errors. I want logs at the DB errors, so coming with the virtualization error, or coming with storage errors. Now that I have these clusters, I want to see the volume of logs for each of these error types and how they trend over time. And I can predict based on the historical data, your DB errors are going to go up. Maybe something is happening there, and you need to take a look at it. So this is slightly advanced pipeline. This goes through 2 steps. One is, of course, goes through first the clustering, goes through the processing, vectorizations, followed by the unsupervised clustering. It clears the clusters. And then on top of that, for each of the log clusters, we pass it to the regression model. So it creates a cluster volume baseline. And as the new logs come in, they get classified into the clusters. Then they go through regression, and we say, hey, this is anomalies. I suddenly see a huge spike with the DB errors, and that's an anomaly, and that you need to take a look at it and make sure that something is going wrong, and you can prevent an outage, right? So when you predict things going to go up, either the utilizations of certain CPUs going up, or the DB errors are going on, and they tend to be going in the wrong direction, and we can send a notification based on the threshold value to the operator so that they can go and say, okay, maybe my disk space for the DBs are reducing, or the logs are taking up the disk space. I need to clean up the logs. Or my CPU is going very high. I need to see which applications are taking too much of CPU cycles, and see I need to do something there. So as I think Teja did walk you through this, but here is how we use this in UI is we provide a heat map for the log cluster volume. So these are the different clusters, and right now we didn't choose to rename. It could be renamed this generic cluster names to DB errors or disk space errors. And then it shows you the darker the color, the higher number of alerts you have for that hour of the day, right? So you can go and look at this and see where things are. So rather than having to look at 30,000 logs, you look at 3 clusters and how your logs are trending for all those 3 clusters. So this is a very, very powerful use case, and we definitely not just use it, but we actually leverage this in our UI to indicate, hey, there is an error, there is an issue that is coming out based on the regression values. So one thing that we have done besides our own ML algorithms and models, we also have integrated with external third-party ML tools. And the primary example being OpenAI. We also have done with Azure and AWS, and OpenAI being very powerful in the natural language processing. And there is, people are on the queue to sign up, but we are able to sign up to OpenAI, get access quickly, because we have a very unique usage of this, very unique use case, that is for ITOps. How do we use NLP for ITOps, right? And as Teja mentioned, one area that we look at is how do I use it for classifying tickets. So if you're getting a lot of tickets, and most of our customers have different teams that look into different aspects of the issue. Someone looks at the hypervisor or virtualization issue. Some team looks at the networking, L2, L3, wired, wireless networking issues. And there's a team that looking at email, all your collaborations like Slack or MS Team messaging and all of that, right? And when a ticket comes in, the ticket description or summary may not be enough, may not have the right words for the person who's assigning them to say which team should look at it. And if it gets wrongly assigned to a team, then the ticket will bounce around and the MTTR gets adversely impacted. So what we use is we use OpenAI for doing semantic search. You don't have to have the right words. You don't have to have the email. You don't have to have the network. We do a semantic search and categorize. So this thing can be completely automated. So if you have ServiceNow tickets and they're coming in, and you can pipe it through our OpenAI integration, and then you'll produce what issue category it belongs to. So let me kind of quickly show you that. So let me go into tags now. So I have this set of tickets from Snow. I have integrated with the Snow. It is actually getting from the Snow instance, ServiceNow instance. And I would like to categorize all these issues into, let's look at the data now, OpenAI, that's fine, data. So there are about 66 rows. It has a lot of columns, but what is really interesting is the description, right? So the description would help us do a semantic search to map it to the right issue category. So I pass the data and pipe it to the OpenAI. And OpenAI has different engines for NLP. DaVinci is the most powerful engine. Of course, it costs some money. So you have to be careful how much of tokens you pass, so that every token counts towards how much usage you're doing it, and that reflects in your bill. So we have our credential that we have signed off for API integration, so we can use that. But if you have your own OpenAI credential, we can also use that for running different classification, NLP-based classification, and leverage that. So here I pass the data and then pass it to my OpenAI. Let's write DaVinci model, and we are restricted. I know there's no instance at 66 tickets, but I'm going to only classify only 5 of them, because it'll take a little longer time to classify all of them. So let's run through this. It got the 66 tickets, and let me look at the columns that are of interest to me. Description, and I think issue category. So here are the description. I'm unable to connect to the email service. It got email access problem. So I can assign it to someone who's doing all the collaboration, the team that manages the collaboration. My computer is detecting headphone device, or cannot access data or files, right? I cannot remember my password. It's a login issue. Currently running 10GR1, need to upgrade to 10GR2, got assigned to generic problem. So as I said, we only classify the top 5, and this is that got classified into different issue categories. It can be automatically taken and updated into the Snow itself. We can go and add a new column or update one of the existing column with the issue category. and automate the assignment process, or someone can look at this issue category and assign it to the right team. So this is, and then maybe I'll, here is, I can show you a little bit more on the command line tool that we used. Let me go through the OpenAI classification Python. So, and I pass it to DaVinci library and say, hey, VM is out of resource, right? This is the description of the incident. This is to show what we've done with the script level also. And if you've seen, I have created about 7 or 8 different categories, L2, L3 network, email, storage, generic issue, hypervisor issue. And this particular VM out of resource, it doesn't have anything to do with hypervisor, but it mapped it to hypervisor issue. The score here is the highest. Score that highest matches the closest to that. So it understood, because it's a huge database for natural language processing. From that, it understood that VM is actually a hypervisor, right? So then this can be assigned to the hypervisor team. So that is one thing that we've done is, classification based on the description and map it to the right category, right? So the other thing that we have done is, as Tejo shown you some of this, once the incident gets assigned to the right group, right team, and finally goes to the right person, and when the person looks at it, they look at it, some exception, and then here is a stack trace, and they're not able to make anything out of it, because an L1 support engineer doesn't understand what is this exception, what is this SSL thing coming on. So this is the OpenAI playground tool that we're using. I'm setting it to here are the different engines that you can set. Babbage, DaVinci. I'm going to use DaVinci. What is critical? What is the response length? So this is very critical. It gives you back a response. It summarizes this into a more understandable terms. And you can set it to 50 words, or let me say 64 words. Temperature to 0. If you don't give temperature 0, every time you run it, it tries to give a different answer. So let me run this and see what do I get when I submit this. So wow, it gave me a very nice response saying, hey, this error is caused by Jenkins is not allowed to access the GitHub API, right? Rather than me trying to understand what the exceptions are, I got a one-liner explanation of what this is. And not only that, it gave me the summary, it also tells me how do I fix it, right? So you need to go to Jenkins user page, go to repo user email, and add the user to it. It stopped here because I selected the response to be 64 words. If I give more words, it'll give me more details about how to solve this, right? So we of course integrated this also using our CFX-DX. We also have integrated this using command line. Here is something that I would like to do is I have the same file here. And I will pipe it to so I'll run my summarization tool and pass this file as a text, and let's see what this comes back with it. And here they say, hey, this error message is pretty clear. And sometimes it can be changed based on this thing. I run it again. It says, hey, the problem is the Jenkins server is not able to verify the SSL certificate of the GitHub server. Right? So it gave me a good, nice summary of this exception. And then from there, I can quickly go and, also based on the recommendation, I can quickly go and resolve the issue and basically reduce the MTTR. So this is we're really excited about our ML solution, our own ML stack, integration with external ML tools, and also the OpenAI, and specifically solving the ITOps issues rather than just focusing on other things. We're very focused on ITOps and AIOps, and I think this gives us a very good platform to solve the real case problems. So that brings my demo to end.